Lesson 117 has to do with a couple concepts. First of all, equations that include x squared. For example, let's do x squared equals 4. And then it'll go to kind of a related concept. It'll have to do with squaring things and radicals. Pythagorean Theorem. I know that's a mouthful. Try saying that out loud if you don't mind sounding like a crazy person. Pythagorean Theorem is going to have to do with geometry and triangles and missing sides when we have, an A, a B, side B, and then side C is called the hypotenuse, and how to find out what is the length of the hypotenuse. But let's go back to equations with x squared. You maybe haven't thought about it before, but there's actually two answers to this equation. You say, no, it's got to be 2. It's got to be 2 squared equals 4. But I'm going to say that's not true. It could be -2, because negatives times itself equal a positive, right? Therefore, the answer to x squared equals 4 is positive or -2. That would be an acceptable answer for that. We can use that symbol to represent both solutions in one, positive and negative. It's important to remember that the radical sign, which looks like this, remember radicals with square roots and things, indicates that only the positive or the principal square root could be true. So square root of 4, for example, it can only be +2. This radical sign indicates it cannot be a negative. Okay? Now, if we need to solve then for, let's say, p squared equals 16, what is my answer? And give you a clue, it's not 4. So what is it? Positive or -4. Make sense? Talk to me if that doesn't completely click for you. Let's move on to Pythagorean Theorem, a geometry concept for finding the length of the hypotenuse. Now, that's a funny word, hypotenuse. I have a good joke about it. Feel free to ask me later. But hypotenuse, if we're talking about this being, like we said, side B, give me a brush. All right. Side B, side A. We call this side C usually, and C is what's called the hypotenuse. Not a word we use very often. Otherwise. That hypotenuse is the slanty line, basically. And we've talked a little bit about why the hypotenuse is in fact longer than the height or the base because of it being a diagonal. If you think about you are at point, let's say you're standing here, it's faster to go like this than it is to go from here all the way up to here. But it would take longer than it would if you were over here and you wanted to go that way. So this is going to be shorter than this would be. This diagonal, a diagonal is longer. Or maybe I should say, like with a TV screen, and they tell you, is this a 42-inch? Is it a 60-inch flat screen? They measure from diagonal to diagonal because that's going to be the longest measurement. This is longer than if you were to go this way. No matter what, even if it's like a square. Okay, so how do we find that? The theorem that was developed by a Greek guy, his name was Pythagoras, born on a Greek island, learned that in a triangle, what is true is that a squared, take the square of side A's length, add that to the square of side B's length, and guess what that equals? Side C's length squared. A squared plus B squared equals C squared. Therefore, let's say we know that A is, let's go with the classic 3. And we know B is the classic 4, and you're going to memorize that this is always, C is always a certain measure in this case. But let's just practice with the theorem. Whenever we plug in numbers for letters, we always want to use parentheses to make sure everything is done correctly. And we got some squares. Okay, you see what I got here? I got the Pythagorean theorem with open spaces for the values for A, B, and C. Now let's plug in our values. 3, 4, and we don't know. C. 3 squared is, now we can lose the parentheses and say 9, plus 4 squared is 16. Finally, we just know C squared, lose the parentheses. Add like terms. 9 plus 16 is 25. C is still squared. Now, how do I solve for C? How do I get rid of this little square, this little exponent? I take the, let's use yellow for this, square root of both sides. What's the square root of 25? What times what equals 25? It's a perfect square. It's exactly 5. And that will equal, by taking the square root, we lose the C, or the little 2. And it turns into just C. So C equals 5. And 3, 4, 5 will always be the case. The hypotenuse is 5. Now, if we hadn't known B and we just knew C was 5 and A was 3, we could solve the same way, but solving for B, and we would know this is 3 and this is 5. You can use the theorem no matter which one you're missing. Okay? So the Pythagorean theorem states what? That side A's length squared plus side B's length squared equals the hypotenuse squared. Write this onto your cheat sheet so you can use it in the future. Then take a look at page 369, example 117.5, real fast. It says find M. And it's got a triangle like this. It's got a triangle like that. And it says that, that this is 7. This is 9. Okay? If that's true, we're missing what? Side M, it says. Let's put the M here, make sure it doesn't get cut off. If I know A squared plus B squared equals C squared, which one's side A? Well, it doesn't matter a whole lot, but let's just say M is side A. So we're missing M. Don't forget it's squared. Plus, what's side B? 9 or 7? 7 squared. And C squared? 9. Now, M is still squared, but this equals 49. What's 9 squared? Good practice for our squares. 81. No like terms here, so we need to subtract what from both sides? 49. What's 81 minus 49? We're going to have to take the square root of that to finally solve for M, right? So that I can get rid of this and have M equals. So what is this? 81 minus 49 is 32. Now you may see an issue here already. If this is 32, I don't know what 32 is squared. Or what its square root is. So if I take this, I'm going to end up with not a very good answer. It's just square root of 32. There's no answer for that. That's the best I can do. Therefore, this side is worth whatever the square root of 32 is. That's the most exact way to write that. Don't try to turn it into a decimal. I'm talking to you, Josh. Don't bother with decimal points. Just call it square root of 32. If you're interested in why this is the case and you want a demonstration to show exactly how to prove a squared plus b squared equals c squared using areas of squares, check out page 369 and 370. And then practice problems, pick either A or B, and pick either C or D. That means I need 2 total practice problems written out. Your assignment is lesson 117's problem set due Tuesday, unless the days are off. Okay, thank you for listening.